Clearly, the most important part of kinematics is to be able to specify the position of certain objects, possibly in relation to other objects. An obvious example is that an astronomer needs to be able to know where an asteroid is relative to the Earth, along with many other similar examples. The way to do that is through the use of coordinate systems. Coordinate systems are needed to describe positions of a particular point in space, and it can either be one-dimensional, two-dimensional, or three-dimensional. So a one-dimensional line requires one coordinate, for example, milestones along a highway. A two-dimensional plane requires two coordinates, for example, points on the Adobe Photoshop canvas or GPS coordinates on a map. A three-dimensional space requires three coordinates. For instance, if we wish to describe the position of an airplane, we need three pieces of information or three numbers, which are two GPS coordinates plus the altitude or the height above the ground. A coordinate system consists of a fixed reference point O. This is what we call the origin. We will also need a set of specified axes with scales and labels, and we also need instructions on how to label a point relative to the origin and the axis. These are the vectors. Kinematics in two dimensions work in the similar way as in the one-dimensional version. We need to describe the position, velocity, and acceleration of a particular object. In two dimensions, the position vector is simply r equals to xi plus yj. The velocity vector is the time derivative of position, therefore v equals to dr dt. Differentiating a vector simply means differentiating the individual components separately. We do not need to differentiate unit vectors since they are constants. The acceleration vector therefore is the time derivative of velocity, and the components of acceleration are obtained by differentiating the velocity components accordingly. Since any vector can be split into their individual components, their respective directions would obey its own set of one-dimensional kinematic equations. So the x components of the position, velocity, and acceleration vector can be analyzed on their own, just like a one-dimensional problem. Then the y components of the position, velocity, and acceleration are similarly analyzed separately as another set of one-dimensional problem.